the ion sulfate, SO42-, draw all 6 resonance structures. Instead, we're going to do phosphate ion, and we'll figure out how many resonance structures there are. For the phosphate ion, we have 5 valence electrons for phosphorus, plus, or this time I'm going to say 4 times 6, so 4 for the 4 oxygens times 6. And there's a -3 or a 3- charge, which means that we're going to add 3 electrons for charge. And this time I'll circle them to show you where that 3 is coming from. If we add this up, we get 32 electrons, 32 valence electrons, 32 electrons for this Lewis structure. Now, phosphorus is the least electronegative. So put it into the center, connect it by single bonds to each of the oxygens. Then sprinkle the remaining electrons around the rest of the Lewis structure. So far I have 2, 4, 6, 8 electrons. Then let's do 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And again, I only have 32 electrons. Now I'm done putting electrons in. Our next step in the process is going to be to make sure that everybody has an octet. Everybody has an octet, so from that standpoint, we're good. Then do a formal charge analysis. If we do a formal charge analysis, what we will see is that just like in previous videos I've made, each of these oxygens has a -1 formal charge. Any questions about that? If not, then phosphorus, which we haven't done before. So formal charge on phosphorus. Well, we know what the answer has to be because we know that the overall charge is -3. There's 4 minuses total, so it has to be +1. It turns out that phosphorus in group 15 in the periodic table has 5 valence electrons. And then it has, this phosphorus has 4 bonds plus 0 unshared electrons. Its formal charge better be +1, and it is. So we put a little plus there. Now it turns out that phosphorus, being in the 3p area of the periodic table, can have an expanded octet if it helps to minimize formal charge, which it will. So let's see, phosphorus can have an expanded octet if it helps to minimize formal charge. Right? The only reason we ever use these expanded octets is to minimize formal charge. If you get to this point and there's no formal charge, then you wouldn't need to do an expanded octet. Okay, so there's a +1 here. That means we're going to form 1 double bond. And I'll draw it over here because I know there's a bunch of resonance structures coming up. So I've got 1 double bond on this left oxygen. Everything else is the same. And I've still got 3 negative formal charges, which makes sense because my ion has a 3- charge. But my plus and my minus have now been canceled out. Okay. Now, what resonance structures say, or how you draw resonance structures, is whenever you have a choice where to draw the double bond, draw all choices. So, and I'll put RS for resonance structures there. So I have one of them. I'm going to draw the next one down below it just because that's where the space is. I've got my resonance structure double-headed arrow here. And let's fill this up. And it doesn't matter where you do it. I'm going to do this one next with the double bond up. So I'm going to rotate my double bond all the way around. And so then my third one. And these aren't by any means of any stretch of the imagination done, because they don't have all their electrons in them, and you must draw all of your electrons to get because these are Lewis structures. And then let's see, so left, top, right, bottom, that's a O. And then fill them in. If an oxygen has 2 bonds, then it has 2 lone pairs. If an oxygen has 1 bond, then it has 3 lone pairs. And I know, so many dots, but that's what we got to do. Excuse me. And of course, just make sure that you only put 2 pairs of dots on the double bonded oxygen. Doesn't matter where they are. Excuse me. Those are all 4 of the resonance structures for the phosphate ion. Oh, and I need my formal charges. Shoot, last thing, formal charges. Well, not the last thing, but the next thing. There we go. Because each Lewis structure, each of my resonance structures has to have the -3 charge for the phosphate ion. Now, this question doesn't ask it, but we can ask the question, what is the bond order and you will find that the bond order is the same for all of these oxygens. So let's just, or all of the phosphorus oxygen bonds. So let's just look at this one. This is the one on the right. Doesn't matter which one we choose. And there are 4 resonance structures, and there are 1, 2, 3, 4, 5 bonds. And of course, as we know now, if you put bond order into Blackboard, you would put 1.25, not 5 divided by 4. I've learned that as well. 1.25, and so then those are all of them. All of them are exactly the same. All of the phosphorus oxygen bonds in phosphate have bond order equals 1.25, and that means that this bond, the true nature of it is it's a little longer than a single bond. That's what 1.25 means. But definitely much shorter than a double bond. All right. It is a little shorter than a single bond, and it is longer than a double bond. Yes, that's the right order. Any questions about this one?